Hello, this is Sarah Zanfari. In this video, I'm going to talk about question number 1 of homework 5 of probability and stochastic course. In this question, we have two probability density functions, uh, and we want to uh, we want to find the probability density function of x plus y. And in this question, we should calculate this probability density function using two methods. The first one is convolutional methods, and the other one is geometric method. Okay, let's go through the answer. Uh, okay, so for the first part, which is the convolution, I have written the formula for the convolution, which is the integral, which is this integral. And then I have the f of x and f of y, and I will substitute them in the formula. And for calculating the integral, at first I do the multiplication here, 1 by 1, so I will end up having 4 integrals. And for each of them, for example, for the first one, we have two step function multiplied, and so we know that u is 1, the value of u function is 1 within a range. So for the first one, alpha should be greater than 1, and for the second one, alpha should be greater than z. So we will write down this integral like this with new bounds between 1 and z, and we are assuming that z is greater than 1, so I will write this down as a step function that force z being greater than 1. This was for the first integral. We have 3 other integrals that we should write them down like this. The second integral has u greater than 1, so the bound is the mean bound is 1, and z greater than alpha plus and alpha greater than uh, z minus 1. So z minus 1 is the upper bound. And again, we have the step function for z minus 1 minus 1. So for finding, for here, we need to uh, put the maximum of the bound, which is z minus 1, minus the minimum for the bound. And so we should repeat this for other two integrals. And now taking these integrals are really easy because uh, we don't have any complicated function. It is 1. So we want to take the integral of 1, which is z, and then we need to give the upper bound and the lower bound, so that we come up with this formula. So this is probability density function. We should also um, uh, okay. Um, so this was the first method, which was convolution for calculating the probability density function. The second method is a geometric method, which is very simple and interesting. So in the geometric method, we first try to calculate the probability distribution function, and then after having the probability distribution function, we can take the derivative and we can calculate the probability density function. So the definition of probability distribution function is the probability of z less than or equal to z. So we will substitute big Z with x plus y. So we want x plus y to be smaller than z. And so first we will have a diagram with x-axis and y-axis, and we know that x is defined between 1 and 2. Let me go back to the question. X is defined between 1 and 2, and y is defined between 0 and 1. So this rectangle here, this is the place where x and y are both defined. And then we will plot this line, which is x plus y less than z. And here we need to do this conditionally. I mean, we should calculate this for once for z between 1 and 2, and once for z between 2 and 3. Why? Because the geometric calculation is different. For z between 1 and 2, we should calculate the area of this triangle, but for z between 2 and 3, we should calculate the area, which is not a triangle. So let's go first to z between 1 and 2. So we know that uh, so we know that uh, our line is going to cross the x-axis and y-axis at z. So the difference here is, so the difference here is z minus 1, and here is z minus 1. So the area of the triangle is z minus 1 multiplied by z minus 1 divided by 2. And then you can take the derivative of this very easily to get to the probability density function. Okay, let's go to the other area, which is z between 2 and 3. And because this is not a triangle, it's hard to calculate, we can do something to make it simple. What? We can calculate the area of the bigger triangle here, and then uh, we can subtract these two small parts from that, and these two small parts are also triangles, so easily we can calculate the area, which is z minus 2 multiply z minus 2 divided by 2. But because we have because we have two triangles, we should double it. So at first we calculate the area of the big triangle, which is z minus 2 multiply z minus 1 multiply z minus 2 divided by 2, and then we have these two triangles, and we can easily then calculate the derivative and get to the probability density function. Okay, this was my answer to question number 1.